This week we'll be cleaning messy data using OpenRefine. Most ecological data is generated by humans, and we tend to make a lot of mistakes, which is why a major part of the data workflow is preparing data for analyses. A lot of this involves data cleaning, where errors in the data are identified and corrected, or the formatting is made consistent. In this tutorial, we will walk through the Carpentries tutorial on OpenRefine, which is a free and open source tool for working with messy data. This tool saves so much time and avoids having to make edits by hand. We want to avoid doing anything by hand because automating saves time, it reduces errors, and it makes you a better scientist. The Carpentries is an organization that is recognized by a lot of potential employers, which is one of the reasons why I've incorporated these tutorials into our course. I really want you to pick up these high demand skills that will make you a better scientist, but also make you more competitive when you're applying for a summer internship, graduate school, or another position. This tutorial is over an hour long, so pace yourself. I've provided bookmarks in the video descriptions, so if you need to complete one section at a time, pause or return to the video. If you need to, you can. Let's talk about setup and installation because OpenRefine isn't a traditional program. What's unique about it is that it runs in your internet browser, and you'll need to have Mozilla or Google Chrome installed, and one of these should be your default browser. If you have something else that you use, you'll need to change your default browser for this lesson, and then you can change it back to whatever you normally use. OpenRefine is a Java program that runs on your machine, and it's a desktop application that uses your web browser as a graphical interface. So there's no internet connection that's required even though your browser is open, and none of the data that you import into OpenRefine actually goes to a server or online. So you don't have to worry about that. If you don't have Java installed, you will be asked to install that as well. Once you download and extract the folder, navigate to that unextracted folder and look for the OpenRefine application. If you have issues, which is completely normal, look over the troubleshooting tips in our Canvas page. Remember to download the data file and save it to your desktop or another folder where you'll remember how to navigate to. We'll be working with small mammal data from the Portal project in Portal, Arizona. So why OpenRefine? Well, some journals, granting agencies actually require documentation of the steps that you took when working with your data. With OpenRefine, you can capture all of the actions applied to your raw data, export your modified data set, and this helps keep your raw data separate from your modified data, which, remember, is one of those rules that we learned about to keep data tidy. So data is often very messy, and this tool saves a lot of time, especially for large data sets with hundreds and thousands of rows. Data cleaning is often very repetitive, where you need to make the same cleaning changes to multiple files, and OpenRefine is great for speeding up repetitive tasks. You can find more about OpenRefine at the links that I provided in the video descriptions. Let's start by creating a project in OpenRefine by navigating to our unextracted folder. I have the unextracted folder in my desktop, so I'm going to navigate there. I'm going to select this subfolder until you get to something that looks like this. What we're looking for is this application file or .exe. At least in Windows, it'll have this diamond icon. So I'm going to double click that, and a browser window will automatically open, and you might see this command prompt window open as well, which is completely normal. All right, so you have a new browser window open, and now we can create a project by getting data from, and I'm actually going to try to increase the font on this so you can see it a little bit better. All right, so get data from this computer, choose files, and I'm going to navigate to where I saved the portal rodents.csv. So this is a comma separated values file. I'm going to double click that and select next. It might take a minute, but it'll give you this preview pane, and we can see that the columns are separated by commas. If you had selected a different separator, then the preview would look a little off, and that would be your cue to check that you selected the correct separator. So everything looks okay. I can create the project. Facets are one of the most useful features of OpenRefine. They help give you an overview of the data and bring consistency to that data. A facet groups all the similar values in a column and then allows you to filter the data based on those values, as well as edit values across many records at the same time. One type of facet is called a text facet, and this groups all the identical text values and lists each value with the number of records that it appears in. Let's take a look at this in our OpenRefine. Let's use faceting to look for potential errors in data entry in the scientific name column. Let's scroll over until we can see the scientific name, and we'll select Facet, Text Facet. Then in the left, this window should appear under the Facet pane. Facets are really useful for looking for typos and misspellings, especially in species names. So we see a box with all the unique values in the scientific name column with a number indicating how many times that value appears in the column. You can sort by name or count. For text like this, I find it more useful to sort by name because you can start to see potential problems with your data. For example, we've got a great example here where there's a typo. For example, there's only one entry for these two forms of the spelling, whereas there's 435 entries for this form of the spelling. So with faceting, we could modify these names to match this. But there's an even easier way to do that, and we'll see that in a minute. Before we go on, I recommend pausing the video and completing these exercises, exploring the faceting feature in OpenRefine. So pause the video, work on these exercises, write your responses down in our assignment in the Canvas page, and then come back to the video when you're done. Clustering is another useful feature. Clustering means finding groups of different values that might be alternative representations of the same thing. Clustering is useful for cleaning data sets with misspelled or mistyped entries. So in the scientific name column text facet that we created, let's click the cluster button. We can navigate to our OpenRefine facet that we created and select the cluster button, and you'll see you can change the method as well as the keying function. Let's select key collision function and the keying function as metaphone 3. To be honest, I don't know what distinguishes these. You can find more information on those resources linked below. But what I understand is that there are different algorithms that detect how similar things are from each other. So using this king function, we found 3 clusters with potentially similar records. So in this case, I can confirm that these are all misspellings, and it selects the new cell value based on the value with the most number of records. And here I'm assuming that it's selecting the record with that's just first. So we would need to confirm that that's the correct spelling. All right, and because I've got this zoomed in, I can't see that merge selected and recluster option. I'm going to select that, and it'll automatically change all these misspellings to the correct spelling. And you can play around with different keying functions. For example, if we select another one, we found another record, another cluster, so I'm going to recluster. All right, so you saw an example of clustering. I can close this. Sometimes data in a single column needs to be split into multiple columns. If there is a common separator in those cells, like a comma or a space, then you can use that separator to divide up the pieces of that column. So let's say that we want to split the scientific name into 2 separate columns for genus and species. We do this by clicking the down arrow, choose Edit Column, Split into several columns, and in the pop-up window, you want to change the separator to whatever that separator is. In this case, there's a space between the genus and species, so we want to enter a space here. And so you can't see it, but it's there. And we want to unselect remove this column because we don't want to remove the original column. I'm going to select OK, and I expected 2 new columns, right? One for genus, one for species, and we see those, but we also see the 2 additional columns. And what's happening here is that somewhere in this column, there are hidden blank spaces following the species names. White spaces are difficult for humans to notice when cleaning the data manually, and this is another advantage of using OpenRefine, because we'll see in a little bit how to automatically fix leading and trailing white spaces. It's common while exploring and cleaning a data set in OpenRefine to discover after you've made a change that you really should have done something else first. OpenRefine provides undo and redo operations that make it easy to go back to a previous state. To do this, you select the undo redo option in the top left, and you can see all of the changes that we've made so far. You can click on the step that you want to go back to. For example, let's go back to the previous step, and those added columns when we split the scientific name disappear. And we can reselect it, and those columns in that step reappear. So let's leave the data set in the state in which the scientific name was clustered but not yet split. Words with spaces at the beginning or the end are hard for humans to detect, but those blank characters make a difference to a computer, and we usually want to remove these. OpenRefine makes it easy to remove blank characters from the beginning and end of any entries with its trim leading and trailing white space feature. So in the header for the column scientific name, let's choose Edit Cells, Common Transforms, and Trim Leading and Trailing White Space. Notice now in our undo redo window that the split operation disappeared and it's replaced with the text transform on one cell. So there was a cell somewhere in this column that had leading or trailing white spaces. So now if we're able to split this column using this space as a separator, I don't want to remove the original column. Now, with those trailing spaces removed, now we get the expected 2 new columns. When you are working with large data sets like Neon, sometimes you only want to work on a subset of the data. To do this, we can use the filtering and sorting options in OpenRefine. To do this, click the down arrow in scientific name, text filter, and this filter box should appear now in the window. And you can, let's type in BAI and press return, and you can see that there are 48 matching rows that met that criteria. Somewhere in this column is a BAI character sequence. And we can see that 2 species actually meet this criteria. We see the BAI in the genus name here and the BAI in the species epithet. There's also other features. Feel free to explore OpenRefine. For example, we can show 50 rows so we can see all the data at once. And so faceting gives you a really nice overview description of all the data, while filtering allows you to select a subset of that data. So let's talk about sorting a column using the drop-down menu. You can sort by text. Let's drop down to sort. You can sort by text, by numbers, by dates, even by logical operators. You can modify the position, so maybe you're interested in seeing the errors in the first few rows, or maybe you're interested in the blanks first, so you can play around with those. But I want valid values, and I want to sort this column from A to Z, so I'm going to select OK. Once you sort on a column, additional options appear under that sort option. So for example, I can remove the sort, I can reverse it. So now it appears in the opposite of alphabetical order, and I can also remove that sort as well. You can sort on multiple columns, and the order in which you select the columns will determine the sorting. You can also remove a sort by selecting remove sort. This is the next exercise. So feel free to pause the video, complete the exercises exploring those filtering and sorting features, fill in your responses, and then come back for the final and probably the most impressive feature of OpenRefine. There's one more feature that I want to talk about. This one will really impress your collaborators. It's the ability to generate scripts. OpenRefine saves every change that you make to a dataset in a format called JSON. JavaScript object notation. You can export this JSON script and apply it to other data files that have the same column names. So say you had 20 files to clean and they all probably have the same types of errors like white spaces, spelling errors, typos, and they have the same column headers. Then you can save the JSON script, open a new file to clean and OpenRefine, paste in that script, and run it. So let's see an example of this in OpenRefine. We can create a script by navigating to the undo redo window. Remember, this was the window that displayed all of the changes and steps that we made to the raw data. To generate the script, we select the extract, and it'll show you all the steps that you want to extract. In this case, you typically want all of them. So you can select all, which will generate this oh, that means select all here. Okay, so this is the JSON script. You can control all or select all here and copy, control C on Windows or command C on Mac, or you can right click and copy. Now you'll want to open a notepad in Windows, and in Mac I think it's something like text edit, and paste the script and make sure you save as a .txt. So I want to save this as, remember our file name should be descriptive and concise, so I might name this cleaning steps portal. Okay, and I'm going to save that. And now I can close. Now for this demonstration, I'm going to open a new project. I'm not going to save any of the changes we made. I'm going to open up a new project. So all my changes were lost on the raw data because I didn't export it. I'm going to reopen the raw data and select next. Remember, we get the preview pane. Everything looks good. Columns are separated by commas. And I'm going to create a project. Now, right, say I have 20 of these files and I have all my steps in that text document, that JSON file format. Navigate back to undo redo where we would see all the steps made, and instead of extract, now we're going to select apply. So now we can paste our extracted JSON operations to perform. And I control paste or right click and paste, control V. And I'm going to select perform operations. All right, now I can see all the changes that were made, and I'm ready to export a modified version of the data. You can export the entire project, which will save your steps and the data inside of this type of project. I typically export a comma separated value file, CSV file, because I try to do all the cleaning in a single session, and then I can export the CSV file. But sometimes you can't complete everything in a single session. It automatically appends this dash CSV letters to the end of the file name, but we want to be a little more explicit in our file description, so I might call this cleaned, and I might even give it the date that it was created. And save. And I'll close this window, and you can close your browser, and you can close that um, command this command prompt when you're done. In this segment, we saw the power of OpenRefine for cleaning data in an automated way, eliminating errors, resulting in reproducible science. We spent an entire month learning the theory and tools for making sure that data is tidy, and everyone is doing such an awesome job. I'm so inspired by you all, and I've really enjoyed reading your comments and ideas in the discussion board. Next week, we will start programming in R and learning how you would take this clean data file that we created today in the CSV format and import it into R and start doing some of those cool programming skills.